So the number of issues I want to talk about. It takes a long time to grade these things, and it takes even longer to go through and mark them up. And so I'm just going to do it the old-fashioned way. So let's start. So we want to develop this turtle program, right? And so one of the things we need is a turtle, right? And what's the abstraction for the turtle? It's an object that moves around the screen and can draw lines, right? And so we need a turtle. And let's use the design terminology rather than the programming language terminology. So instead of saying fields, we'll say state. Instead of saying methods, we'll say operations. Right? It's just fancier. So what state do we need? Well, pen status, although there was one person who said, oh, what we really need is a pen. And the pen will have a pen object, and then you'll have a pen, you'll have a status on or off. And then when it comes to actually doing this, right, we can then actually have a draw on the screen. Okay, but we'll stay with pen status. We also need location, right? Where is it physically? And we need a direction, right? But now it's a class, right? So we need operations. What operations do we have on our turtle? Well, actually, this is easy. Like I told you what the minimum was, right? So there was a move, and that's going to need some argument, right? Some amount. There's turn. There's pen up, pen down, and if I there was a direction method to return the directions going in, and there was a location method to return its current location. Right? These are the ones specified in the assignment. And well, these two are just return values, right? And these just set the status, so they're pretty simple. And then what does move do? Well, actually, it gave you the code to do that, right? It moves it, right? So you basically, where you are, the direction, then you do the angle, and you compute the angle, and then you compute the new x and y coordinates, right? And we now have a complete class, right? And we can test it, we can play with it. And one of the key things is we're doing the move in the turtle class, right? Why are we doing those operations in the turtle class? What data do we need to actually figure out if I'm going to move n units, where I'm going to end up? I need the current location, right? The heading and the amount, right? And the current location and the heading are in the turtle, right? So we talked about keeping the data and operations together in one spot. So we have a method in the turtle class called move, and it does the work, right? So far, so good? So now, once we got the turtle class, now we want to run a program, right? And that involves the interpreter pattern, right? And of course, there is one piece of code where we have to read the file and parse it and produce the abstract syntax tree from the interpreter. But now we need, what classes do we need for the interpreter pattern, right? Not worrying about parsing, right? We need the grammar, right? And so we need some abstract class or interface that says, here are the operations that all these elements are going to have, right? And so let's call them turtle program expression, right? Why not just expression? Right. It's an expression. We're going to build an expression for that context, and now the context becomes clear, right? And what methods do all our expression classes need? Yeah, or I'll just interpret or evaluate, right? Okay, now we have a big decision to make. Does evaluate need an argument or not, right? So a lot of people said, no, it didn't need an argument. But then, okay, but for this to operate, we need the turtle, right? A turtle object. And we also have all these variables floating around. We need to access those, right? So what they would do is they would, when you look at the subclasses, each subclass would have a constructor, and then they would pass in the constructor, the turtle, and what the text called the context, right? But that means your interpreter, your parser has to know about that, right? And so the parser now has to have access to the turtle and has to create the context, right? It's like, isn't parsing hard enough without making it do extra work that it doesn't have to do? Plus, what do we lose or gain by passing instead and evaluate? By passing and evaluate, I can postpone the decision with the pass in, so I don't have to have my parser coupled with that knowledge, right? And I can pass in different turtles, right? So I want to pass in what? Well, the book calls it a context, right? But again, that would describe the basic idea of the pattern, right? So let's not call it context. what are we going to put in this context? We're going to put in all the global state for this program, right? And so let's call it turtle program state, right? And now what do we want to put in that? Well, people who implemented context usually just had a dictionary or a map of some sort told the variables, right? So let's put in a map. Well, let's just call it variables, and it's going to be a map. And then we could just also put in a turtle. Oh, it's all the variables that are going to be in the program. Not these, but in our program, when we write a program, we have, remember this? No, it wasn't $sign. Yeah, those variables, right? Yeah. And so now our context, our program, right, turtle program state, right, we can pass into our evaluate, and then we can pull it out, get the turtle out and operate on it. And we can also then deal with the variables. We could also just skip the turtle here and pass it into the second argument, right? Yeah, yeah, yeah. So now our turtle expression, this is our interface, right? Now we need our class to implement that interface, or subclass that abstract class, whatever it is, right? And so what classes do we need? Well, there's pen up, right? Pen down. There's move, turn, repeat, right? And then there's end. There's also assignment, right? Which is that over there. But we also have to deal with two other types of things. One is all those variables, right? So when I do move k, right, I need to deal with that. So create two other classes, constant and variable, right? So far, so good. Let's see. So let's now look at the move class, right? What state does it need? Well, the problem is that, right? If I say move k, I need to evaluate that k, right? But I could also say move 10, right? And now I don't need the variable. How do we deal with the fact that sometimes it's a constant and sometimes it's a variable? What? What do I put for the state in the class? Yeah, and that's all we want to hold, right? How to make sure it's only that? We could create a parent class, right? Of, I don't know, let's call it program data. And so then my move class for its state, right, it can have a right program data, and we can now one of the questions people kept on, some people asked is like, okay, for most of these expressions, when I call evaluate, we don't care, we don't need to return anything, right? We just do something. But for constant and variable, we need that number, right? And so now what we can do is we can basically, in the parent class, add a method, right, to do something different so that when I call it, it returns, and our general evaluate doesn't have to return something. And now, when I implement the move, recall I get a turtle. No, where is it? It's no. What do I get? Yeah, I get. Well, no, when I call move, well, the problem is it's not a move method, right? It's evaluate in the move class. And what does evaluate do in the move class? Well, so I turtle program state dot turtle, right, move, and now I have to get the value out of that, right? Notice there's no mementos, right? Some people in their move class and evaluate, they pulled all the data out of the turtle, they then computed the next location of the turtle, and they put it back in the turtle. I was like, wait, didn't we talk about keeping data and operations in one spot? Um, so at this point now, we can basically implement evaluate in all these classes, right? And it's basically one method, and each time we're going to pass in this program state, and it's pretty much, it's almost like, you guys, this is boring, right? Because now it becomes, the pen up evaluate becomes, argument dot get turtle dot pen up, get turtle, pen down, turtle dot, right, turn. Repeat's a little more complicated, but the repeat has to keep a collection of all the things in it. But then we have to go through evaluate that. But otherwise, all those evaluates are pretty straightforward once we do this, right? We pass it in the evaluate function. No, it's something we create, right? I create before. So what I do is I create the abstract syntax tree. I got a parser and reads the file, and when it's done, it says here is your program to execute, right? And now what I have to do is I have to create a turtle. I have to create this turtle program state or context, and then I can call evaluate on the program. And when I call evaluate, I pass in an object of this program state, or context, if you will. And then it turns out we missed a class here, right? What class did we miss? The root, right? When we do the grammar, right, one of the rules is I need a starting point. Where's my starting point? Our program is one of pen up, pen down, move, right? Or multiple repeats of all these, right? So what does our parser return? When our parser is done, it should hand us a program which is the root of the tree. And what does the program evaluate do? It calls evaluate and all the things it contains, right? And again, that evaluate, we have to pass in the context or the turtle program, right? So far, so good? Right.
So in this case, we have a separate kind of hierarchy, and our functions was probably lie in the other hierarchy.
Right.
But then that we would not do assign to the move because the program.
Well, so his issue is we want to write functions, right? And now the problem is I need to add a function or a method in my class here, right? Now, of course, that's going to be somewhat similar to the program, but with one difference. And the difference is it has a method or a function, right, has its own local variables. And so the question is, how do you handle the local variables in, right, in the program? And that makes this turtle program state a bit more challenging to deal with. Because now we need to tell it, look, I'm going to start adding things to you, but when I'm done, right? So how can we do that? But it also needs the global one too, because we can refer to global variables, right? But when we're done, the local ones need to go away. Any suggestions on how to do that?
The global, for lack of a term, super class. And I mean, I put in the data structure, the abstract, and a dictionary with all the global variables in it, and that was one of the two features of the tree itself. Being, that way, everything being operated on as the abstract syntax tree being executed will have access to that dictionary. Refer to it.
But now how do you deal with programs or methods, functions?
They're more complicated than a lambda. Instead of storing all state, we just create a new inside implementation.
But we then have to say, oh, are you in here? If not, are you in here, right? So why don't we create sort of a wrapper around our program turtle state so that when you add a new variable, it stores its own dictionary. And then when you ask for a value, it first checks its dictionary. If it's there, that's what will return. If it's not there, it then goes and looks in one it holds. And so then when you enter that program, it's going to wrap it around it. And then when you start doing assignments, right, our wrapper is going to check to see whether or not we need to create a new one or not. Wrap the context, right? When you look up, when you say, okay, when you ask for something, is it or there, right? And then when we leave the program state, well, we won't care anymore because when we leave the evaluate, right, that wrapper goes away, which is the way local variables are supposed to work, right? So you start to see how these patterns start to solve, make these seem hard. Some of these problems seem hard, a little bit easier to deal with. Yeah, it just wrap, right? Yeah. So if you want to have functions instead of functions, no problem. Each function just wraps it, and it doesn't have to worry about it. Any more questions before I continue? We're not the visitors yet. This here, this is the evaluate in my move class. This is how to implement that method. And now we go to the visitor pattern. And it's really, really important we understand why the visitor pattern, what is intent, right? And before we go there, let's look at, oh, there was this, we had a number of visitors we needed, right? And I want to add a few more. So what visitors do we need, right? Well, so there's a distance one, right? And then there's, yeah, we can call them mental, right? Let's do why don't we have another one where we count how much rotation we do, right? And maybe we want to count how many operations there are, right? So let's do operation count, right? Or maybe we want to do some complexity, so maybe we just want to count right? Yeah, how many times did we assign something, right? And we can think of all kinds of visitors we may want to do in the future, right? Now, if we look at this distance one, right? What's the easiest way to compute the total distance traveled by the turtle? Forget about patterns. Just what's the easiest way to do it? Yeah, so in our move class, what we can do is every time we move, we keep track of that, right? Oh, but then we also have to do it in the repeat, right? And then so we modify our evaluate function to keep track of that, right? Or we could just have a separate method that goes through and then just basically asks, right, the program data, what your value is, and return, keep track of that, right? It'd be fairly simple. Right? Now, what's the purpose of the visitor pattern? Okay, add functionality without changing the original. Well, we have to change the original a little bit, right? Why? Because we now need, so that's a change we have to make, right? We have to make an accept method, and then our accept, right, method, right? Notice, right, the accept method accepts a visitor. Some people had a different argument for each visitor they created. You go, wait a minute, remember the goal is when we create more visitors, we don't want to change the structure, except for this one change, right? We add accept and accept the visitor. And of course, this method is pretty simple, right? It's basically visitor dot visit, and some people will say visit move, and some people didn't, right? So I'll just say visit move, doesn't matter, and we're done, right? Right? Now, how do we, let's see, so we need a distance visitor, right? And we need how many accept methods? Yeah. Well, how many accept methods does a distance visitor have to have? All of them, right? So for every single class that we may visit, we have to have it. Now, you may have a parent class that has implements null does nothing, and so on our subclass we just do the ones we need, right? But it still needs them. So we definitely need visit move, right? We have to do something there. We also have to do something on visit repeat, right? Why? Because a repeat loop could have moves in it, and those will be executed multiple times, right? And so we need to do something here, and we need to do something there. And we also need some state, right? So here's our state. Total distance, right? And we can start off being 0, and then we'll need a special method to return total distance, right? So let's look at how do I implement the visit move? And what do we get? Well, we could get, well, what do we need? Well, we probably want, well, we need the move expression, right? And, well, I'll just say context because we might as well pass that in too because we need to, the move may need those data, right? And it should be, turtle program state, but that gets to be too long to write out each time. What's that? Well, we'll just do the move first, right? How do I compute the distance?
Each argument into that you are tracking inside of.
And how do I get that?
Oh, you mean
How do I get it? I mean, I got this and this. What do I do to get that distance?
class bits?
Can I access it? Well, using Python, yes. In Java?
Oh, sorry. Yeah, sorry.
How do I access that value? So now I'm going to modify the move class for this visitor. Right? So here is where the visitor pattern becomes tricky, right? We said the whole point of the visitor pattern was we want to make this change accept method, and that's all we want to do, right? If every time I add a new type of visitor in the future, I have to go back and modify all my expression classes, I sort of defeated the purpose of the visitor, right? Particularly since we already said it'd be pretty simple to add a method directly in the move class to compute the total distance, right?
Yes, a way of doing it
without violating encapsulation. The move class will probably be able to see the turtle's location.
We're not in the move class.
Oh,
We're in the visitor. Yeah, so I sort of cheated in that in our turtle, I had a location method which returned the location, right? And so now what my visitor can do is get the location of the turtle, call the move operation on the turtle, right? And then when I'm done, get the location again, and now I can compute the distance. It's sort of painful, right? We're basically undoing the operation we did, but if the goal is, right, for the visitor pattern not to have to change our structure, we want to avoid doing that. Right? I mean, that was the whole point of the visitor pattern, right? Not necessarily. Not every. We don't necessarily have to go backwards every time, right? There are other tricks. There are other tricks we can play, right? And well, in Python, you don't care because all your fields are public, and so you just grab them and do what you want, right? So in Java, you can start thinking about, can we, start putting visitors in the same package as everything else, and then instead of making all the fields private, make them protected. What are the minimal type of things we can do, right? But as soon as we start adding special methods in our structure so the visitor can do his job, that's to be avoided, right? That's the last resort. And yes, there are times, since we don't know what we need in the future, right? Because we could do any one of these things. And so in Java, we can, how do we do this? Well, you just get the turtle out of your, turtle's program state and give me the location, and then we call move on it, right? And then we get the location, and then we can keep the distance, right? If you want to do rotation, it's easier, right? Because it's just one number, right? We can look at the turtle has a certain direction, and then it changes a different direction, and you subtract it, and then you get the difference, and that's how much we've changed. So far, so good. Now, the memento visitor has some interesting things too, right? So instead of distance visitor, we can call memento visitor, right? We don't need total distance. Now, the memento pattern has various roles to play, right? The originator. and the caretaker. What's the role of the caretaker? To save them, right? What's the why do we have a mental visitor? Oh, so what is our caretaker? The mental visitor. We don't need a special mental caretaker class that is just a diction, just an array that has an add, right, method that you then, it's like you create a separate class just to add something into array each time, and then another one to return the array. Just do it right there, right? The mental visitor is the caretaker. Well, there's a problem with the term caretaker and the term originator, right? What are you taking care of? What's the originator? That's the problem. When you describe the pattern, you're describing the structure, right? But when you're inside of a big program, it says originator, what does that mean? It doesn't help you at all, right? When you say caretaker, yeah, you know it's holding something, keeping track of it, but what are you keeping track of? Don't know, right? Keep what type of coupling? Yeah, I mean, its whole reason for the visitor is to go through and collect all the mementos, right? So just let it do it, right? What do we gain by creating another class called caretaker, which holds in the Java case, an array list, and I add a method called add on that caretaker, which adds something into the array list. And another method is here's the array list, as opposed to just doing it right here. What do I gain? And I had to create another class, and now every time I try and understand what's going on here, I have to understand that class, right? And now who's the originator? The turtle, right? So we don't need another originator class, right? Some people really felt we need another originator class, and so they had an originator class, and what they do is they took all the data out of the turtle, and they put it into the originator class, and then they needed to create a memento, and so they took all the data out of the originator and put it in the memento. Like, wouldn't it be easier just to do it directly from the turtle over there instead of going here and there, and then throw away the originator?
Doesn't that harm the ability to extensively? Like, let's say you want just the base.
So I'll create other types of mementos.
So straight up, it's better than to have that. I'll give you an example.
And what's a memento? It contains valid state, right? What state do you need to maintain? We can create a generic memento class, right? Nothing wrong with that. And having a turtle create the memento doesn't prevent another class from creating a memento, right? And so in our memento visitor, what does visit move do, right? Well, we get the turtle, ask the turtle to create the memento. Why do we ask the turtle to create the memento? Because the data we want to save is in the turtle, right? What does that mean? Well, okay, yeah, so now we have to, or we'll modify one of our classes, right? Is that a good thing or bad thing, right? Or should we do it in our memento visitor? The problem becomes we don't have access. Do we have access to all the state, right? Yeah, so how do you copy it, right? And how do you, so that having the turtle does it simplifies things. Now, part of the problem is when you think of these problems, like I said, we can talk about writing a program or create building blocks to create the program, right? And our classes become the building blocks. And when we start off trying to write a program, we start getting people, well, I'll just put operations in a turtle that don't belong there, right? I'll have the parser inside the turtle. And you go, okay, then what's the abstraction of the turtle? It represents an object. You can move around the screen and draw things, and it, right, reads a program from a file. Like whenever you try and describe an abstraction and you go, it does A and B and C, that's a sign that the class may be doing too much. It's doing several different things. Why not put, you want this visitor to keep track of all the mementos, why not put it in the turtle, right? And have the turtle to keep track of its entire history.
One or two things.
Yeah, we want the class to do one or two things, preferably one. Two related. Well, so the history is sort of related, but now the class gets more complicated. And then you say, oh, if I'm creating the history, well, maybe I also want undo, right? And now I have undo, and then I got redo. And do we want to do that in the turtle class? Well, in this case, we didn't need to because the whole point was to do the visitor. Now, if we weren't going to do the visitor and you really wanted to put them through a class, I'd say, no, why don't you create a separate class that contains a turtle, that pretends it's a turtle, and then keeps track of just the history. And every time you do a move on it, it calls move on the real turtle, so that again, I keep the things separate, right? There's a basic operation of turtle, and then keeping track of the history. I don't have to think of them at the same time, the same place. Well, but you're adding more functionality, right? But it's using composition, right? So since no one has asked, why am I wearing half a shirt? What?
Or something to do with design. There's a lesson here. There's a lesson trying to figure it out.
What? No, I took this shirt and cut it in half. Not the visitor pattern. No. What's that?
Reading hand.
No, I'm left-handed, so that side's usually warmer. Why are people writing half of a class, right? There are a number of people that had, oh, the turtle class was just a structure. Can you the data? And then, oh, they put the operation to move in the move class, right? And then, oh, the rotation to actually change, they put it inside the rotation expression class. So the number of people who were like, oh, the originator, it was just a structure, right? It was like, why we took all the data out of the turtle and put it in there and then took it out again, right? It was just, it contained the fields and methods to put things in and methods to get them out. It's just a structure, right? Now the memento really is just a structure, right? But that's for a particular purpose, right? You want to save state. So you want to be careful, right? I mean, there are times when you want to write a program, but there are times you need, I'm building building blocks to write the program. And when the mindset is write the program, things get started put in places they. Yeah, a bunch of them. Right. Well, but they all do different things. But what's the difference? The only difference is what do they visit, right? And since we don't know what the visitor may want to do in the future, right? You basically want to visit everything. And it may be, for example, in the distance one, we don't have to visit most of, we don't do anything when we visit most of them, right? But
Back to the topic, building half. You're talking about switch program writers in class.
right, yeah. Yes, yeah, you have a structure over here and the operations over here, right? Not a class from day one, right? Oh, some people, their turtle was just a state, no operations. Yeah, but so some people, their turtle class was just that. That's truck. Yeah. Oh, but they come over here and they do all the. And some people even went further. It was like they did have a move class, right? So turtle did have a move, and then a mount, And how do they implement it? What's that? So what they did is, right, move equals new move, what I just called, I guess, move object. Make all these classes, put the operations here, and then over here, they instantiate that class. And now I can say move, right, dot evaluate, right? And then you pass in this. And so there's like, why are you making life hard? Because it's easier to implement the move here where the data is, and then this class just calls that method on the turtle.
Program has data structure, its operations.
They're just functions, right? There's a class. What's that? Utility method, but yeah, they're just, yeah, there's. Trying to figure out how it works is painful, right? Because now you have to bounce around and say, okay, I come here. Now I have to say, how does this work, right? And so I have to come over here and see how this works, right? And then you go up, how does this work as in the tree structure? I didn't keep track of how many times I saw it, but I did see it more than once. The most common mistake was, oh, I'm doing turtle and I'm doing AST and I'm doing visitor, so I'm going to combine them all together in some way. No, I'm going to have a get distance method in the expression tree, right?
Like that eliminates the traversal part of the visitor.
Well, no, you said the visit, and it did. So what some people did, you actually executed it, and then the move class would store a special value, and then you could call a special value back. Right. Right. Because you're writing a program, right, and you're doing this and this and this, and so okay, it just makes it easier to do that way. But you're not thinking about, oh, I'm building classes and the intent of what the visitor pattern is supposed to do. Right. Or you don't want to. That's the whole point. I mean, now that's also one of the things that you don't understand about the visitor pattern to have to do it in real life, right? Is that, what happens if you want to pick up a visitor, but you cannot access the data you need, right? Then what do? And like I said, the last resort is you then modify the structure, but you want that to be the last resort rather. Now, in Swift, it's not a problem because you can just add an extension to a class you want, and then and you can even make that extension file private, so it's only available in one spot, right? In Python, it's not a problem because you can always access everything, right? So it becomes a language-specific issue. And then Java, you can start playing with changing protection levels and putting packages and muck with that. No, some people forgot about that. And some people, I'm going to copy, but then they forgot, I'm copying over an array list. And then I have to ask the Python experts. You've got two different types of built-in structures, right? Right? And this is a list. Is it mutable or not mutable? Right. And what about that? Is it mutable? So if in your turtle class, right, you were storing the location as a tuple, you didn't have to worry about copying, right? It's immutable. If you stored it as an array, you had to, and it wasn't. You use tuples, yes.